Welcome to the Crazy Hat Chemist. So another video here on thermochemistry. So let's get moving here. Bam! So today we're talking about heating curve calculation number 2. Let me read the question for you. So how many joules are required to change 2.36 grams of ice at negative 3.25 degrees Celsius to steam at 120.00 degrees Celsius? Okay, so that's the question. Now we need to do the first things first, and that is make a generic graph. What we need to do is make a generic graph. Here's our generic graph. Now, I've already gone over the generic graph of a heating curve, so you really need to review that lecture here so you know what all the parts are to it. It's all based on two essential points. Those two essential points are the two horizontal sections of the graph. The first lower horizontal section is the freezing melting point. The second higher horizontal section of the graph is the boiling point. And those 2 points define the graph. Okay? All right. From that, then we need to figure out, well, what's our lowest temperature in the problem? For this particular problem, the lowest temperature is negative 3.25 degrees Celsius. So where does that belong? Well, that is below the freezing point of water. So that is below the first horizontal section of this graph. So I'm going to put a dot right there. And now it doesn't have to be accurate or precise, but it just does need to be below that first horizontal line. That's where it needs to be. Okay, now then the next question is, what is the highest temperature that this problem reaches? It reaches 120 degrees Celsius. So that is above the boiling point. So the boiling point is the second horizontal section of this graph. So that means that this final point right here needs to be above the horizontal section of the graph. That is the second one. Okay, now what we're going to do is we're going to do everything in between the two dots. That is essentially we're going to connect the two dots together, and we're going to do everything in between those two dots. Okay, so what steps are those inclusive of? So those are steps numbers 1, 2, 3, 4, and 5. Okay, now each of those steps has a different constant. So that's why you need to look at the generic heating curve problem as an example. That is the foundation, and that includes all the constants for each specific step. Steps 1, 2, 3, 4, and 5. Okay, so what we're going to do is steps 1, 2, 3, 4, and 5. Here is the first step. Here we go. That's 2.36 grams that we're starting off on the left-hand side of this. And then we're to cancel out units. That means we need grams in the denominator, and that 18.01 is the molar mass for H2O, that's water. That is equal to 1 mole in the numerator. And then in the yellow here, what drives this step number 1, is the constant. And the constant is 37.8 joules per mole Kelvin. Okay, that allows us to cancel out the moles. Then the last white section of this on the right-hand side of the yellow is the final temperature minus the initial temperature. And the final temperature is 0 degrees Celsius. That's the melting freezing point, minus a negative 3.25. Now, I have these actually in degrees Celsius. You could have them in Kelvin, but the beautiful thing about degrees Celsius and Kelvin is that the interval is exactly the same. That means if you go up 1 degree Kelvin, you go up, if you go up 1 degree Celsius, you go up 1 Kelvin. If you go down 35 degrees Celsius, you go down 35 Kelvin, okay? All right, so that's step number 1. Now what we need to do is step number 2. What drives step number 2? Step number 2 is driven by the constant at step number 2. The constant for step number 2 is the heat of fusion, and that is 6.01 kilojoules per mole. Now we're going to look on the far left-hand side of this, and you got the 2.36 grams. Those grams need to cancel out, so you got 18.02 grams in the denominator of the next term, and then in the numerator is 1 mole. That's the molar mass for water. Okay, then the moles are going to cancel out. Now if you reread the question, it says how many joules, so it's specifying the units of which you are asked to solve for in this problem. That's why on the last portion of this step number 2, we're doing 1 kilojoule per every 1,000 joules. That way our units will cancel out such that we have just joules remaining. So that's step number 2. Now we need to do step number 3. Step number 3 is the heat of fusion for water. Okay, now if we use the molar heat of fusion for water, that's about 75 joules per mole Kelvin. But I gave it to you in joules per gram degree Celsius on the generic heating curve. So Either one would work, except that this step here, I do not need to include the molar mass for water because the 2.36 grams cancels out directly with the specific heat capacity for water, and that is grams in the denominator. That's 4.184 joules per gram degree Celsius, and then it's the final temperature minus the initial temperature. Okay, and that final temperature is 100, that's the boiling point, and the initial temperature is 0. So for that section of the graph, which is step number 3, that is the constant and that is the temperature range. Okay, that's step number 3. Then we got step number 4, and that is the heat of vaporization, the molar heat of vaporization, and that is 40.7 kilojoules per mole. Okay, so on the far left-hand side of step number 4, here I got 2.36 grams. Then the denominator of the next term, I got 18.02 grams. That's the molar mass of water. That's equal to 1 mole. I got the constant, that's in yellow, the heat of vaporization for water. And then again, the problem is asking for joules for my final answer for units. So therefore, I'm going to go from kilojoules to joules, and that's 1 kilojoule is equal to 1,000 joules. That's step number 4. Then the final step is step number 5, and that is driven by the specific heat capacity of steam, the molar specific heat capacity, and that's the 36.5 joules per mole Kelvin. Okay, so on the far left-hand side of this, I still have the 2.36 grams, and then the next section of this math problem here, I got 18.02 grams per mole. That's the molar mass for water. I got the constant, and then I got the final temperature at 120, and then the initial temperature at 100. Okay, those are all the 5 steps individual. Okay, now there are times in which your instructor might not give you the molar heat capacity of ice or the molar heat capacity of steam, and then therefore you could potentially add up and sum up steps numbers 1, 3, and 5 and include that into one step. But if your instructor or professor gives you individual constants for every single step along this graph, then you will have to do 5 steps if it's a 5-step problem. Okay, so now what we're going to do is we're going to mathematically get each of these sections with rounding them to the correct number of significant figures, which in each case is 3 significant figures. So my first step is 16.1 joules. My second step is 787 joules. My third step is 987 joules. My fourth step is 5,530 joules. My last and fifth step is 95.6 joules. Remember, these are all in joules. Now, our last thing that we're going to do is we want to get the total amount of energy required in total to take 2.36 grams from negative 325 degrees Celsius all the way to steam at 120. So what we're going to do is we're going to add up all these yellow figures here, paying particular attention. When we are adding, we are using the least number of decimal places. So we will not have a number in the ones column. There'll be a 0 there, but it will not be a number other than that. It's just a placeholder. And here is our final number. That is 7,220 joules for that problem here. That's how much heat is required to convert 2.36 grams at negative 3.25 degrees Celsius all the way to steam at 120. All right. That was an all-inclusive problem. Make sure that you know which constants you're using for every single step. That is really what drives it. Before you start the problem, make sure you make a generic graph. Okay, that generic graph gives you a picture. As they say, a picture tells you 1,000 words, and that starts you off with that problem. So you know where your low point is and your high point is, and you're just doing everything in between those two. All right, I'm the Crazy Hat Chemist. I got a good crazy hat here for you, and I think it's a giraffe. Okay, woohoo! Give me a thumbs up if you like that video. Subscribe to my YouTube channel. Find me on the internet and the web. I got a great website set up with all my videos and all kinds of great worksheets as reinforcing material for you. Check it out. I'll see you next time. Bye for now.